All right, in part 3 of Unit 1.1, parent functions, we're going to discuss all the different parent functions that we will cover in this course. All right, and look at their key features that we talked about with the vocabulary words in the video before. So the first one is a constant function. Notice it says f of x equals c. We're used to, when we're graphing, seeing y equals. So just recall that f of x is actually the same thing as y. F of x is function notation, meaning that the graph that you make will pass the vertical line test. All right, so in this example, when you have a constant function, we're really graphing y equals to -3. So if you remember that when we talked about lines, the y equal one, we used the word hoi when we had y equals to a number. So that means that this line, the constant function, is actually a horizontal line. So under here with the shape, I'm just going to write horizontal line. So the shape is just for you to write something in here that helps you remember what the graph looks like. All right, so with the horizontal line, no matter what I pick for my x values, my y values never change. They're always -3. So you can pick any x values that you want. I always pick a couple negative, 0, and a couple positive. So that's what I would look at here. I would just put in -2, -1, 0, 1, and 2. So those are my go-tos. Again, you can use anything you want. And when you graph them, -2, -3, -1, -3, 0, -3, all the way to 2, -3, and you connect them, you can see that you have a horizontal line. All right, so some of these key features of the horizontal line is the y-intercept's always going to be where it crosses the y-axis. So it's going to be the point 0, -3. The domain of this, remember domain is x values, so it's what x values does it hit on this line here. And if you look, it looks just like the x-axis. So that means it hits everything. So that's where we can use our all real numbers. Or if you like interval notation, we're going from -infinity to infinity. All right, remember negative infinity, we read left to right to infinity. All right, range is y values. So if you look here, we only hit one y value. That is -3. So in set notation, we would say all y values such that y is equal to -3. All right, that's the only one it hits. Or if you like interval notation, since it only hits the number -3 and nothing else, we would put brackets around the -3. All right, next one is a linear function. So notice the smaller word in linear is line. So you did this one a lot in Algebra 1. So our parent function is f of x equals x, which is the same thing as saying y equals x. So that means if I pick any x values that I want, so if I pick my 5 go-tos, -2 to 2, whatever x is, it's going to be the same as y because x and y equal each other. All right, so when I graph these points, you can see that you are creating a diagonal line that goes through quadrants 1 and 3. All right, so our shape we said is going to be a diagonal line. All right, remember 0 is the same thing as saying what's the x-intercept? So our x-intercept on this graph would be 0, 0. where it crosses the x-axis. The y-intercept is the exact same point, so it crosses here at the origin. All right, increasing interval. So when you see the word increasing, that's where you're going to trace left to right. And notice if I start here on the left and I trace it, I'm increasing forever. So the whole entire graph is increasing. So remember we use the x values? So if the whole graph is increasing, that means it's starting out here at negative infinity and it's increasing all the way to infinity. All right, domain again is what x values does this graph hit? And when we have arrows on the left and arrows on the right, that means I could straighten this graph out and make it look just like this horizontal line. So that means it's going forever on both ends. So again, you can do all real numbers, or you can do from negative infinity to positive infinity. Range is your y values. Remember the y-axis goes up and down. So if you look, you have arrow pointing up and you have an arrow pointing down, which means that it goes up and down on both ends. So negative infinity to positive infinity, or all real numbers. All right, positive and negative interval. All right, so this key features have positive and negative interval in this one. So if you want to, I like to highlight. Remember that positive is everything above the x-axis. So if I look at the x-axis and I look above it, that would be this piece here. So positive, we're going to go above. And then negative is below the x-axis. So that would be everything here. So negative is below. All right, remember the x-axis itself is neither. So this point right here is not in the positive or in the negative. It's kind of where it changes directions or changes from positive to negative. All right, so we use these x values. So I need to know this x value, and this x value is 0. So the green one is in between these two x values, negative infinity to 0, all parentheses, because you're not ever hitting negative infinity. And remember, we just said 0 is not positive or negative. All right, and then the yellow, which is the positive piece, is in between these two x values, 0 to infinity. All right, absolute value. Remember, absolute value is the distance from 0 on a number line. So for example, if I said, what's the absolute value of negative 3? I want to know how far it is from 0 on a number line. So negative 3 would be 3 away. All right. So that means if I pick any x values, I'm asking myself, well, how far is negative 2 from 0? It's 2 away. How far is negative 1 from 0? 1 away. Obviously 0 away, 1 away, 2 away. So notice that these y values are always positive because distance is always positive. That's a y. All right, so if you graph these, all right, what you see that the graph, the shape of it is a V. So we just say it has a V shape. The zeros, again, is the x-intercept, so it hits the x-axis at 0, 0. The y-intercept, where it hits the y-axis, so it hits right here at 0, 0 again. All right, so this one has a minimum point because it has a lowest point and it doesn't go any lower than that point. So the minimum point is 0, 0. The rest of the graph is above it. All right, domain, x values. So remember, we read these left to right. And a good way to look is at the arrows. If you have an arrow on the left and an arrow on the right, that means it's going to go forever towards negative infinity and forever towards infinity. So that would be your all real numbers or your negative infinity to infinity. So however you want to write that. Range, remember, is up and down. So you want to look for arrows pointing up and arrows pointing down. Well, notice I only have arrows pointing up and I have a minimum point. So that means I don't have anything pointing down. So if I was going to do this interval notation, then I want to start at the minimum point and go up towards infinity. So remember, up is infinity. So I would say 0 with a bracket because 0, 0 is an actual point to infinity. If you like set notation, you would say all y values such that y is greater than or equal to 0. All right, decreasing interval. So remember, decreasing and increasing is when you trace. So if I was to trace this, on this side, notice that it's going down. So this side's decreasing. Then it hits this point, and then this side is going up. So it's increasing. And again, we use these x values. So I look here, and the decreasing is in between negative infinity and 0. Again, 0 is where it changes, so we do not use a bracket, we use parentheses. And then increasing, the increasing is in between 0 and infinity. All right, the last piece is positive versus negative. And notice that this says just positive only, doesn't even say negative. That is because the graph is above the x-axis. So everything is above the x-axis except for one point. And that one point is 0, 0. So all of this is above and all of this is above. So the only thing you've got to pay attention to is that this one point right here is neither. All right, so I'm going to write this in two separate pieces. So I'm going to say from negative infinity, again, remember we're using the x values, so negative infinity to 0, union 0 to infinity, because I don't want to include 0, that's infinity hooked together. All right, I do not want to use 0. 0 is not positive, it's neither positive nor negative. So that's why I use the parentheses and I split, so everything but 0 will be on my list of positives.